I'm Rizchel Dayao. I'm a software engineer here at Skookum. I'm focusing on the front end, but before I did a little bit of DevOps, I've done a little back end, so a little bit of everything. I work in the Denver office, so just here visiting in Charlotte. Previously, I was a developer advocate at IBM. That's where I focused really on Kubernetes, containers, serverless, kind of more of that kind of stuff, and that's what I'll be talking about today. So, who's this excited to learn about Kubernetes? With a raise of hand, come on. Okay, I really just like this GIF, so I wanted to use it. But how many people have heard of Kubernetes? Raise your hand. Okay, so mostly everyone here. How many people have worked with Kubernetes? Okay, so a couple hands here and there. Okay, so I hope you guys all get something out of this. I'll be kind of going over what is Kubernetes, why do you use Kubernetes, how can you use Kubernetes, kind of all those questions. And this is our agenda for today. So first, I'm going to be doing a beginner level, introduction to Kubernetes. Then I'll be going over Helm and Let's Encrypt. That's more the intermediate topic. And then the more advanced is our service mesh Istio. So Kubernetes version 1 was first released on July 21st, 2016. So it was actually introduced by Google in 2014, but it wasn't really available for general use until 2016. So that was about 2 years ago, and as you can see, it's getting a lot of wide adoption, it's getting a lot of awareness, so it is kind of becoming a rapidly big technology tool that we can use. Kind of a fun fact about this is anytime you use any Google products, so Google Docs, Google Slides, anything like that, it all runs on Kubernetes. So what is Kubernetes? So I kind of like to look at this as kind of two prongs. So first, it's a tool to manage containerized applications. How many people are familiar with container architecture or using Docker? Okay, so I'll kind of go over more of what that architecture is in the next slide. But basically, you have your microservices. All of those are going to be, in containers and containerized in your environment. And basically, you can manage those containers rather than each individual application. The other part of it is it's an orchestration tool. And basically what that means is you can manage and automate all your deployments and all your services. So instead of having to individually do small tasks for each of your applications, a lot of that is already managed by Kubernetes. So your DevOps engineer or anyone doesn't have to go in for every little thing that you want to make a change to. And then last, it can be considered a portable cloud platform. So on any of the big cloud providers, so Google Cloud Platform, AWS, Microsoft Azure, you can use it there. So it's really nice, depending on what environment you're using. You can kind of use the same basis of technology. The commands are going to be a little bit different just because of how the environments are, but you can use it in multiple different places. And then it also uses that container microservice architecture, which I'm going to go over in the next slide. So what challenges does Kubernetes solve? Basically, these are the big 4 questions. This is a very high-level overview. This is why you kind of get more into Kubernetes. These are the ones that I really think are cool from a developer perspective, and what I'm going to go over how it solves these problems. So first of all, what will work best for my microservice architecture? So microservice architecture is really big right now. Before, we used to go from these monolithic applications, which, when you think about deploying, if you have a big application, let's say you have a front end, a back end, a database, anything else, with monolithic architectures, you used to have to basically deploy that all at once, scale it all at once. Basically, it was all just one thing that you always had to manage. With the microservice architecture, you can take your front end, containerize that. You could take your back end, containerize that, database. So what this kind of gives you is it gives you the flexibility to manage and deploy these containers individually. So if you have a front end and a back end team and they want to make changes to their code, instead of having to deploy that whole application, you just have to deploy, a specific container. And basically what this does is with containers, it provides isolation. So you have all your dependencies for a particular container, but it does share at a kernel level. So rather than each having its own kernel, like we did for virtual machines, it shares the kernel. So you have resource sharing. So it's kind of 2 ways you can look at it. You have resource sharing, so it's not very bloated. You don't have you're not using a lot of CPU, a lot of memory, or as much. And then it's also isolated. So your back-end dependencies don't also need your front end. And basically, so back to answering this question, It was kind of long-winded. But microservices can be packaged into these containers. And what Kubernetes does is it creates an abstraction of that containers and deploys them to pods. So basically you manage the pod rather than the container. And what you could do, this still provides the same thing that microservices and container architecture do, which it isolates it, so you have all your dependencies in your pod, but you could also share resources between your different pods as well. So next, what happens if my application crashes? So it provides monitoring for your pod health. So let's say you have a pod that crashes. Let's say it's your front end, it crashes. Kubernetes is always monitoring that, and if it does crash, it'll automatically restart it. I actually had this happen with one of my applications, and I didn't know until the next day, and I looked at the logs that it did crash, so that's really cool. I didn't get like a late night call that it crashed. It just automatically spun up another pod, and it was working. So from a user perspective, they don't see that it crashed or anything like that. And then next, how can I release rollbacks or updates? So basically what Kubernetes does is you have a set of pods, and that's deployed out into your environment. People can access it from the web. If you want to do an update, instead of taking down all those pods, and let's say you'll have downtime on your application, your users can't get to it, anything like that, basically what Kubernetes does is it will incrementally create pods with those updates, and then it'll take down the existing pods. So from a user perspective, you don't see that it was ever down. You just kind of see the new updates that it had. And it also does the same with rollbacks. So if you accidentally introduce a bug and you need to roll it back, it does the same kind of thing. And then the last one is what happens when I get an unexpected influx of traffic. So this is really nice because it automatically scales the number of pods. So I'm sure some of you have gotten a late night call and says, okay, you need to go and scale it. We didn't expect this many users to come. For some reason it has happened, and then you need to go in at any hours of the night. So with Kubernetes, it automatically scales those pods. So if you have a lot of traffic, instead of just having one pod, it can scale however many that it needs to basically account for all that traffic. So these are the basics of Kubernetes. You have cluster, your node, and your pod. So cluster is going to be the biggest element within the Kubernetes ecosystem that you are going to interact with. You kind of create the cluster. You can do this either in the UI, you can create this on the CLI, anything like that. But this is basically the foundation of it. It's what's going to hold your whole application. And it's basically a cluster of computers that are connected together. It works as one unit. So instead of having to tie specific applications to specific machines, it's going to basically all be within this cluster of computers. Next, you have your node, and this is where all your containers are going to run. So this can be a physical machine or a virtual machine, but these are all managed by the cluster master. So here you can see in the diagram, you have your big cluster, and then you have your master, and I'll go over kind of everything that the master does in the next couple slides. And then last, you have your pod. So this is an abstraction of your container. So rather than managing your actual container, it's going to make an abstraction on top of it, and that's what you manage instead. So the cluster, so again, it consists of the cluster master and multiple nodes. Your cluster master will determine how many nodes it needs. You don't need to set a specific amount of nodes. Depending on your traffic and how much resources you're using, it's going to spin those up automatically. And basically what the master does is it handles kind of everything from a top-down level. So it's going to communicate with your nodes. It's going to do all the scheduling. So if you need to create more pods for scaling purposes or whatnot, the cluster master is what's going to tell your nodes, hey, you need to spin up more pods. And the nodes have specific quotas and stuff as well. So if it reaches that quota, it's obviously going to create another node. And another thing it does is it handles the distribution of the network. So again, it's going to kind of take all of that information and data it gets and then kind of parse it out among your nodes. And then it's going to manage the workload lifecycle. This is actually what's going to handle that scaling, like I've said before. And then it can consist of one or more nodes. So the node, again, this is the smallest unit of computing hardware in Kubernetes. You actually don't really manage the node at all. You manage more of the pod. But the node represents a single machine within your cluster, and then you could have multiple if you need as well. It contains the services required to run your pods. So this is anything like resources available, so what's the maximum number of pods, what's CPU, memory, that's what handles all that information. And then it's managed by the cluster master. So last, we have the pod. So this again, when you think of a pod, this is a group of containers. It could be one or more containers. I would say when you're starting out, a good rule of thumb is having one container per pod, just because if you put more containers, you can use a lot of resources. You can kind of max it out. It can become really slow, anything like that. So you really just kind of want to try to do one, and then as you're getting like more experience with it, then you can try and do more groups of your containers in there. And basically, they're all deployed together, and they all talk to each other on the same host. And again, when we're saying deploy together, that means that all the resources that they're sharing, so if it's all getting scaled up together, that's going to happen all within the pod. So if you have multiple containers within one pod, and if you need to scale maybe, let's just say your front end more, if your front end, your back end, your database is all in one pod, it's all going to get scaled up because everything happens to all the containers in a single pod. This contains your shared network and resources. So again, this is more of your resources, your dependencies. So when you're creating an image for your specific containers, this is it's gonna all live in the pod. And then this is considered as a unit of replication. So when you need to create new replicas, it's going to replicate the pod. It's not going to replicate, more nodes for a specific container. It's going to replicate the pods. So when you need to spin up or need more pods, that's what it's going to do. And then last, like I said, limit the number of your containers to your pod. So don't try and put like 5 containers in one pod. That's probably not going to work. Start with one, see how that works. Maybe add another and see how it handles it. So next, I'm going to go over kind of how you can deploy and create a service for your Kubernetes cluster application. So first, we have our deployment, and this is how you deploy your pods to the cluster. So this is what takes your code from your local machine or wherever you have it living and basically pushes it up to Kubernetes. Next, you have your service. So you're going to need to expose the application that you just deployed, whether it's to other pods within the cluster, whether it's to the outside of the cluster, to the web, to other services, anything like that. You always need to expose that. And then Minikube. So how many people have worked with Minikube? Okay, so a couple. So Minikube, I would recommend starting with Minikube. Just because if you use like a Google platform, or not Google platform, a cloud platform, you're going to have to do like the sign-up process. It makes you do a bunch of things. But basically what Minikube does is it creates a single cluster within a virtual machine, and then you could just manage your cluster and everything locally. So you don't need to it's very easy setup, and it's all local. And then Kubectl. So there's kubectl. This can be called a lot of different things, and I'm sure you've all heard it. I call it Kubectl, but we're not going to get into that discussion just because there's a lot of different ways you can say it. But this is the CLI for running commands on your Kubernetes cluster. So this is going to be the CLI that you can use on Minikube and across multiple cloud platforms. It's all going to use Kubectl. They're going to have their own form for handling like the registry and that kind of external stuff in Kubernetes, but more of your Kubernetes actions, it's all going to be managed by this CLI. So first, you're going to have your deployment YAML file. Everything in Kubernetes is YAML files. So just a warning, when I first got into Kubernetes, I did not like YAML files. So I actually found a way to deploy an application without using YAML files. So if you guys want to know more about that, you guys can see me after. But this way is all YAML files. So basically, a lot of this is kind of metadata. And as I show you more and more YAML files, you're going to see a lot of boilerplate. So it does become kind of a lot of copying and pasting. But here you can see the API version. This, I think, is the previous version. I think it's on version 1 now, but this is always changing. And then you kind of have your kind. So in this one, it'll be your deployment. In our next one, it'll be a service. You could also have like volume persistence if you use like an ingress controller, anything like that. And then you're going to have your name. and then how many replicas you want. So in this one, I would just do one. If you're doing a more enterprise environment, you probably want more replicas up just in case you have one that fails. And then more on labels. So these labels become, I think, more important as more advanced you get into Kubernetes. At first, you could definitely specify things by labels, but kind of when you're dealing more with Helm and whatnot, labels do become more important. And then the last thing is the most important part. So for any of your applications you're going to need to containerize it first. So you could use Docker to containerize it, or you could use like a public Docker image from like the registry. But that is a prerequisite that you need. So if you guys want to learn more about that, I can give you resources later. I'm not going to be going over that. But basically, you're going to need a Docker file, and then you're going to need to containerize that or pull it from a public registry. So then you put your name of your container, your Docker or your container image, and then whatever port that you want it open to. So next we have your service. So we've created that deployment.yaml file. We have our deployment up there running in Kubernetes. Now we need to expose it, and you can expose it to, other pods. You can expose it outside. This I'm doing more outside of the cluster, but I can also show you more like within the cluster how you would share it. So again, it's a lot of boilerplate. On the top, we see the API version and kind, and then more metadata. And then the important part is where you see type node port. There's multiple types you can do. Node port is usually, if you're using a cloud platform, it's usually the free version that you're going to get. You could also do load balancers, ingress, which those are definitely better for more of an enterprise environment. But when you're kind of starting off, if you don't want to like pay extra money for it, you just kind of want to test it, node port's the way to go. And then so you specify your node port and then the port that your container is available at. So you need to make sure that that port is the same port that your container image is also available at. The first time I did this, they were different, and it took me about a day to debug what was going on, and I found out it was just showing at different ports. So that's very important. And then these are the commands that you're going to use to basically take those two YAML files and deploy it up to Kubernetes. So everything, whenever you have a YAML file, it's just going to be kubectl create -f and then whatever the name is. So this is going to create your deployment first, then your service, and you can get deployments, get services. That gives you more metadata about that. You could also do get pods. That gives you more pod information, anything like that. So once you've kind of done all that, then you should be able to access the application. So Minikube automatically sets this IP address all the time, but as you'll see the last part after the last colon, that's the node port. So if you kind of go through that setup, you can hit it there, and then you can go to that node port as well, and that should be available there. So that concludes the kind of beginner portion of Kubernetes 101.